This lesson is on differential equations with variable separation, and so the problems for this one are going to look like what we had with implicit differentiation somewhat. You'll have x's and y's together. And here are our steps. The first thing that we have to do is separate the variables, and typically x is going to go to the right and y is going to go to the left. And again, this is a very important step. And usually on the AP exam, you get 1 point just for separating your variables. So please pay attention and do that first. Then it's very similar to our previous lesson. We're going to integrate both sides. You're going to use plus c only on one side, and I typically put it on the right side. It just seems to work out better for me. Then we'll plug in the given information just as we did before and solve for c and plug it into the equation we found. The other step that's a little bit different is 6, and we typically want to solve for y after we've done that. They won't be already solved for y sometimes. Just like yesterday's equations were all y equals or f of x equals. These may not be. So let's move to some examples. Okay, so you'll notice our first example is really similar to or looking to what we did in our previous lesson. They're giving us a derivative equation, and they are giving us given information on the original. So they're telling us x is 1 when y is 2. So the first thing that I like to do is change, if I'm in y prime notation, I change to dy dx notation before I separate my variables, because I can just think of it like when we were doing u sub, I can think of them separately. So separating my variables means tending to get the y's to the left and the x's to the right. So the first thing I'm going to do is multiply by y on both sides to get rid of it over here. And I'm going to multiply by dx so that it puts the dx with the x variable and the dy with the y variable. And so I have now y dy equals 2x dx. Okay, so that's my separating the variables step. Now I'm going to take the integral of both sides, just like we did before, but I'm actually going to write the integral on both sides now. So again, we're going to treat y not any differently. It's just going to be treated like we treat x. So this is just a power rule, 1/2 y squared. Our 2x and a derivative of that would be x squared, and then I'm going to put the plus c on this side. I'm at the point where now I can plug in and figure out what c is. They told us that x is 1 when y is 2. So if I plug 2 in for y and 1 in for x, 2 squared is 4 times 1/2 is 2. 1 squared is 1. And then if I subtract, I get c to be 1. So if I go back to that first level where I'm looking at that antiderivative, I now have 1/2 y squared equals x squared plus 1. But then our last step today is to solve for y. So I'm going to multiply by 2. So I'm going to get 2x squared plus 2. And then I'm going to take the square root. So my y is going to be the square root of 2x squared plus 2. Now, you want to pay attention. Square roots, when you take them, can be the positive or the negative version. And so you want to consider that given point, and they told us y is 2 when x is 1. They're looking at the positive in this case. Had they given you a different output, a negative output, you would be looking at the negative, which can be important in some AP level questions. Okay, example 2. Again, we're already in that nice dy dx notation for me. So the first thing we're going to do is separate our variables. And I'm going to keep the x's where they are, but I'm going to move the y. So the way I have to move the y, since it's y squared, is divide by y squared. And to get rid of the dx, I have to multiply by dx. Now when I say divide by y squared, you have to think of that in terms of powers because we're getting ready to take an antiderivative. So that's a -2 power. And over here, I just have the 3x left and my dx. dx is canceled here. So I have y to the negative 2 dy and 3x dx. My next step is to take our integral, and it's important that you put that notation in there. And so here, again, treat y normally and just power rule it. So it would be negative y to the negative 1. And then over on this side, I would get 3/2 x squared plus c. And again, I'm just putting the plus c on one side. Now that I've taken my antiderivatives, I'm ready to plug in. This one's going to be a little easy because y is 1 and x is 1. So negative 1 to the negative 1, 3/2 times 1 squared plus c. So 1 to any power is 1, and then we have the negative out front. So this side becomes negative 1. And then over here, 3/2 times 1 is 3/2. And then I just need to subtract the 3/2. So 1 is 2/2. So negative 2/2 minus 3/2 is negative 5/2. So I've found my c. I'm going to go back to the antiderivative level. So negative y to the negative 1 equals 3/2 x squared plus c. But since it's a negative 5/2, I think I'll just write negative 5/2 here. Okay, now last step is to solve for y. And anytime I'm trying to solve, I don't want the power, I want the fraction or the root, if it's a root. So this would be negative 1 over y, because it's a negative equation and it's a negative exponent for the y. So I have 3/2 x squared minus 5/2. Now this comes back to what I taught you maybe in pre-calc about getting rid of fractions. So I want to get rid of the y on the bottom. I want to get rid of the 2's on the bottom so that I don't have fractions anymore. So I'm going to multiply everything by 2y. And over here my y's are going to cancel and I'm going to get negative 1 times 2. On this one, my 2's will cancel, and I have 3 times x squared times y. And on the last one, my 2's cancel, and I have 5 times y. But again, I'm trying to get the y by itself, and you're like, well, I can't combine 3x squared and minus 5. You can, you just have to think about it the right way. It's a GCF over here of y. So if I take out y as a GCF, I get 3x squared minus 5. And then I'm trying to get y by itself, so I divide by that. And so this would be my final answer. Alright, example 3. They've given us a much nastier equation. We're plugging in 0 for y and negative 1 for x. But if you will just think about it, to get the y part to the other side, you want to flip and multiply. So I'm going to get that to the other side that way. And again, multiply by dx so that it moves to the right side. And so I have y over the square root of 1 plus y squared dy. All this canceled over here. So I have 3x dx. So I've got my variables separated. The next thing is to take the integral. And the thing about this one is this side over here with the y's is a u substitution. So let me do that in a different color. Our u is going to be 1 plus y squared. So du dy would be 2y. And since there's not a 2, I'm going to divide and have 1/2 du equals y dy. So this is going to be 1/2 integral. The y dy is going to go away, and this is u and a square root on the bottom. So u to the negative 1/2 du. Now, when I take that antiderivative, I have to bring down the 1/2. This will be 2u to the 1/2. So the 2's will cancel, and I have u to the 1/2. Which really is 1 plus y squared to the 1/2. So this whole side comes out to be 1 plus y squared to the 1/2. this side over here, I didn't have to do a u sub. It was just a power rule, so I can go ahead and bring that on down, do my power rule. So that will be 3/2 x squared, and I'll put the plus c over here. So this one just was a little bit more complicated. I had a u sub on that side. But I have done my antiderivative. I'm ready to plug in my stuff. So y is 0 when x is -1. So I have 1 plus 0 squared to the 1/2. 3/2 times -1 squared plus c. Well, 1 plus 0 squared is 1 to the 1/2 power is 1. -1 squared is +1 times 3/2 is 3/2. And so c ends up to be, when I do 1 minus 3/2, c ends up to be a -1/2. So the level where I had the actual antiderivative is right here. So I'm going to come back up here and write that down. I have 1 plus y squared to the 1/2 equals 3/2 x squared minus 1/2. So I'm plugging in for the c. And then our last step again is to solve for y. So the first thing I have to do is get rid of that 1/2 power, or it's the square root. And to do that, I square both sides. So I'm squaring this whole side and squaring this whole side. And the 1/2 power and the 2 cancel each other out. So I have 1 plus y squared. On this side, I'm just going to write it all in the square and not distribute. There's no point. Subtract the 1. And then take the square root of that side. And that is ugly, but it's still something that you can work with. Now again, with the square root, we're thinking about our outputs, and this one's kind of hard to tell because they said y was 0, which is our output, which is neither positive nor negative. So I'm just going to leave it like this and say, hey, if they had given us some different stuff, we could determine whether we needed the positive square root or the negative square root. Okay, so I want to conclude this lesson by looking back at the steps again. Separate your variables. That's really important to start with. The other steps are really similar to what we did before. We'll take integrals. You treat y normally. Plug in, find c, and then the last step is a little bit different. You actually want to solve it for y. So the two things that are different are that first thing and the last thing, and just pay very close attention to your details and your signs and things like that. And that concludes this lesson.